Good morning, Twitch, and welcome to EkoSystem Day, building modern applications with containers on AWS. My name is Nathan Tabor, and I'm a Senior Product Marketing Manager here at Amazon Web Services, working specifically with our containers products. Today, we're going to be walking you through how you can use containers and Amazon Web Services to build powerful, scalable, performant modern applications. So let's go ahead and get started. What do we mean by modern applications, and how do containers help us build the next generation of applications for your business? First of all, when we talk to customers, we've noticed that in order for companies to be competitive, to grow quickly, and to stay alive in the market, they have to be able to innovate as rapidly as possible. And this isn't just at the business level. This happens on teams and for individual developers as well. So in order to innovate, you really need two things. You need the ability to try a lot of experiments, and you need to not have to live with the collateral damage of failed experiments. And really what that means is that we have to build to enable rapid innovation. So how do we build quickly to try things out and then also be able to roll back and make changes if something doesn't work? So what we've noticed among a lot of our customers over the last few years is that they're building applications in a really specific way. And what they're doing are these 6 things. They're simplifying and standardizing the environment management where their code is running. They're automating the operations for their code. They're reducing the size of the changes that they need to make in order to get code into production. They're rapidly releasing those code changes. And they're getting full visibility. They're instrumenting so that they can see every part of an application. And then they're protecting their customers and the business across the application lifecycle. So how do we do this? We simplify and standardize our environment with serverless technologies. Our customers are using serverless to make sure that they can quickly spin up a performant environment for every stage of the development process. They're automating operations using code to model applications and infrastructure. And then they're architecting their applications as microservices, reducing those sides of code changes that they need to make. And then they're rapidly releasing code changes using CI/CD and DevOps processes. They're getting full visibility across applications using monitoring and tracing. And they're protecting their customers and their business by enabling security and compliance across the application lifecycle. So these are a few of the things that we're going to be covering this morning. We have a really great agenda lined up full of AWS speakers and some of our partners that are building technologies that work on AWS for you. And let's dive into a few of these concepts and then go ahead and introduce the rest of the day. So serverless is the first item on our list. Serverless allows you to focus on creating business value and removing the heavy lifting of managing a compute environment. So it fully manages that compute environment, the messaging and orchestration, the storage and databases, the compute, and the physical infrastructure, so you can focus on building APIs and building business logic. At AWS, we have 2 options for serverless compute: AWS Lambda for functions and AWS Fargate for containers. Today, we're focusing on containers, so in a little bit, we're going to talk a lot more about how Fargate works. Second, to really think about how you eliminate manual errors and reduce the surface area for how things are done, you need a consistent way to set up and deploy the environment in the application where your code needs to run. And we do that by treating everything as code. So the entire infrastructure that your application runs on, so creating that serverless architectures, and then also actually defining how your application works and how it works together using infrastructure as code. And we'll have a few partners that are going to come and talk about that in depth today as well. Third, by re-architecting applications into microservices, we break them into small pieces that work together, and this reduces the size of our code changes when we make a change to how our application runs. And when that impact of the change is small, your velocity can increase. So this makes your applications more resilient, and it makes them faster to change if something needs to be changed. And fourth, teams that practice CI/CD, we've noticed ship code a lot faster. So it's not just about reducing the size of the change, it's building that automated process around the change so that every time a developer checks code in, you have an automated set of tools that test and deploy that code into production. And our customers that implement full CI/CD processes see a 5x lower change failure rate and a 440 times faster commit to deploy time. So this really accelerates their ability to try new things and then to make changes in the case that an experiment fails. Finally, monitoring is critical. When you have large distributed systems, especially with microservices and lots of changes that are happening with CI/CD and infrastructure as code, you need the ability to find where problems are happening and so that you can resolve them quickly. And so enabling monitoring across the application lifecycle means implementing metrics, logs, and traces, debugging and automatic alerts, and real-time insights into how your application is performing. We have quite a few partners today that are going to come up and talk about how you can enable monitoring at different parts of your containerized application. And then finally, security is important. Security is a common thread that runs throughout an entire application. And a lot of times, the first place we should start is security and compliance. So it's last, but certainly not least. A cloud environment is made up of a lot of things: code, data, APIs, open source packages, commercial software. There's a lot of different dependencies that go into that application. And you need the ability as a developer to authenticate access to your resources, to authorize any changes that are happening across your application, to audit and govern application behavior, make sure that it's performing the way that you expect it to perform, and then validating each step as that code is written, checked in, tested, and deployed. OK, so here's our checklist that we've talked through: building with serverless technologies, using code to model our applications and our infrastructure, structuring our apps as collections of microservices, rapidly releasing features using CI/CD processes, gaining insights into how our application runs with monitoring and tracing, and then building security and compliance into the entire app lifecycle. OK, pretty simple, right? Just a small checklist. So what we think about at Amazon is how do we actually help our customers do this? And we view this as a shared responsibility model. Our goal at AWS is to automate and abstract away as much of this as possible so that you can focus on building applications for your business. And our goal is to make you successful. OK, this has been really nice. It's a good high-level intro, but you're probably wondering right now, where do containers fit into this? Why do containers even matter for this? I thought this was a day about building with containers. OK, we're going to do a really quick primer for everybody on the stream right now that may not know what a container is or how it works, to show you how it enables all 6 of these items. So first, containers are a packaging mechanism that give development teams the ability to take the runtime engine for your code, the dependencies that that code needs to run, and the actual logic that you've written, and package that into a consistent unit of deployment. So this artifact is also called a container image, and it's something that you can deliver to any machine and have confidence that it's run because it's going to bring along all the things that it needs to run in any environment. So that's pretty cool. And what it means is that I can have different environments from my laptop to my staging QA to my on-premises or even my cloud production environment. And when I deploy that container, it's going to run the same way everywhere. And this solves some big problems in terms of how do I build and quickly release code and increase velocity across my deployment pipeline. So containers, because of the way that they're built, are a key enabler of modern applications. Back to the checklist, they run the same everywhere, which enables you to have serverless compute because you can have a consistent environment. The application and dependencies for your software are literally defined as code in the container image. It's easy to use containers to break up applications into microservices because you don't need to write the fully baked library into every single piece of code or start it on a VM. You can just define those dependencies right alongside your application code. The standardized packaging, as you saw, enables easy automated testing and deployment. I can actually automate the process because from the outside, every single container looks the same to my automated delivery pipeline. And then my consistent implementation model, because those containers look the same, I can implement standardized monitoring and tracing across all of my services. And then finally, containers come with built-in versioning and dependency declarations that make it easy for me to audit what's inside and to build security mechanisms around the code that gets deployed. OK, that's good. How does AWS do this, though? What are the things that we're going to be covering? So today, we're going to be talking specifically about ECS and Fargate. But AWS has a bunch of services that specifically help you run containers in production. So we have Amazon ECR, which is our container image registry. This is a secure, highly compliant, very scalable and available container image registry where you can actually store those container images as part of your deployment pipeline. we have two orchestration engines, Amazon ECS, which is a native AWS container management engine that uses AWS APIs. And we have Amazon EKS, which is Amazon Elastic Container Service for Kubernetes. And that's a Kubernetes-based container management engine that makes it easy for you to run Kubernetes-managed applications in production on AWS. And then for hosting, we have two types of compute engines for running containers. We have Amazon EC2, which is our Elastic Compute Cloud, highly available and scalable virtual machines. And then we have AWS Fargate, which is a newer service, but this is our custom-built compute engine just for containers. And it allows you to quickly run containers in a serverless way without worrying about setting up and managing your infrastructure. Great. So in a second here, I'm going to go ahead and hand this over to two of our great developer advocates, Tiffany Jernigan and Justin Graham, and they're going to walk you through the rest of the day. Let's take a look at what that looks like. So we've perfectly set ourselves up to talk about this. We're going to start with running serverless containers with AWS Fargate. And then we're going to move on to how we enable security and compliance with our partners Apotero, Twistlock, and Aqua. And then we're going to have monitoring and logging using AWS CloudWatch, CloudTrail, and our partner Datadog. And then we're going to end the day talking about CI/CD with AWS Code Build, Code Pipeline, Zebia Labs, and Pulumi. So I'm really excited to welcome Justin Graham and Tiffany Jernigan up here to kick us off and start talking a little bit deeper about how we use AWS Fargate to run our containers in a serverless way. Great.